My name is John Hammink. I'm the lead quality engineer for, or when I say lead, it means I'm actually one of the first test engineers for a fledgling product that started in late 2011 called Boot to Gecko. So originally, I've been living around Europe. I've been traveling around. I worked for Skype when it was a startup in 2004. Set up the certification program there. Worked a bit with QA and some other functions as well. Got a lot of traveling in. Before that, I was in Finland. That's kind of where I got my start of my career, is hanging around all these really smart Finnish people, working for this company called F-Secure in the late 1990s. And I was able to take kind of everything I learned and move it over to Estonia and then teach people there, because when I moved to Estonia in basically 2001, the tester was the person who made the coffee, so there really wasn't much of a career there at the time. And I got a chance to sort of plug that and evangelize it and be hopefully a little bit enthusiastic about it at the same time and get people excited around the idea. Well, sooner or later I came back to the States and did a contract here and a contract there. And eventually Mozilla and I found each other, and it's been a great time ever since. So in late 2011, I moved out to exciting and starstruck Milpitas, California. And I was approached to do a bit of work with this thing called the web APIs. And I'll get a little bit more into that, but that's a little introduction to me. Stepping back, what is Mozilla different from other things? Well, we're nonprofit and we're fully open source, right? Have any of you guys ever seen the movie Code Rush? So there was a movie around 1998 called Code Rush. That was the moment in time when Netscape actually diverged the code and decided to make, some people at Netscape decided to make all this Netscape code open source. Because at the time, as you know, Netscape wasn't doing very well. You had exactly one choice of browser, and it was Internet Explorer. And they wanted to make more choice. So that's kind of the whole point about Mozilla, and I've gotten this conversation with various people. What's the point of Mozilla if we don't dominate the market? Well, it's to create more options, to create more possibilities for people out there. So that was one of the things we tried to do there. So we're coming out of Netscape AOL. We're doing the open source thing. A lot of what Mozilla leverages is community contribution, right? So we have people all over the world who are very enthusiastic about what we do, and they want to contribute. They want to join us and write code and write patches and write tests for us. And these are people who are doing it out of the love of doing it. And I want to say that's one of the things that kind of sets us apart. Obviously, we're a strong proponent for web standards, so we got this great lecture from Rebecca earlier. She was talking about web standards. I mean, a lot of our guys, Andreas Gall, Jonas Sicking, sit on these standards bodies. Brendan Eich, who works with us, was one of the creators of JavaScript. Actually, he was the guy who more or less invented it. One of the guys who worked with the Selenium, Dave Burns, is actually one of our people as well. So we have a lot of these things that are sort of starting here and going out into the world, and it's a very exciting place to be, because you see the genesis of a lot of ideas, and then you gradually see people getting enthusiastic about the ideas, and the ideas take root and they go places. Mozilla exists, of course, to promote innovation and choice on the internet. We want there to be more possibilities. We want more people to have more opportunities to do more things, including that guy who's yawning back there. He can yawn because that's his right to yawn. So let me tell you a little bit about Firefox OS. So in late 2011, I was doing a contract, and it sucked. And then Mozilla came along, and they said, why don't you do this thing with web APIs? So what I'd been doing a few months before that, or maybe half a year before, is I was over in Finland working for Nokia, and I was working on the MIMO operating system, and my job, God help you if you were subject to it, was to make test applications based on different basically based on different APIs. So it was given this list of APIs and say, make a test application that demonstrates animation, make one that demonstrates drop-down lists and all of these things. And we'd make these corny little applications with basically one control on them, and we would have the automation bang on them. And so what I was going to do when I went to the web API thing was to do the same thing, is to make a test applications that worked with, instead of C++, it was JavaScript, which of course to me was completely new, and I had no idea what I was doing, which of course it's a challenge, right? So cool. So I got to work on the web APIs, and suddenly we discovered that I discovered there were all these web APIs for things like telephony and SMS and all of this, and what does this have to do anything with a browser? Well, we'll get to that. Fast forward, or should I say rewind, a few months back to July of 2011. Chris Jones and Andreas Gall and Brendan Eich were sitting around. I know this sounds like a punchline's coming. And they were actually working on PDF.js, so the PDF handler for plugin for browsers. And they started to realize, when we add more plugins to browsers, the performance of the browser actually gets worse and worse. It gets crappier and crappier because, right, the plugins are actually amending what's executing in the browsers. You have the browser, there's all this code, execute all of these things, but then you have this plugin up there that says, no, wait, don't do that, do this instead. And every time an amendment is made, every time you add a plugin, you're getting kind of worse and worse performance for the browser. So somebody had the idea, why don't we take a lot of what's in these plugins and just plug it right into the Gecko engine of the browser and make it a little bit more performant. So suddenly out of this PDF.js, people started to think, well, what if we had a telephony API? What if we had this thing could run on a device and it could access the same things that you would use to make a phone call, or you would use to send SMS, or you would use to access your accelerometer on your device. So they started thinking about making all these APIs to fill in the gaps. And there was a flurry of activity, and a bunch of specs were written, and W3C stuff happened. And it was, there you go. 1.5 years later, we launched at Mobile World Congress, and we announced 17 carrier partners who wanted this thing. So it wasn't just a whim. It really took off. And it seems to be that I'm riding the wave of another thing that's going meteoric again. So I can say that we have at least 3 OEMs, something like 17 partners. It's really moving. So that brings a bunch of interesting questions, though, because Mozilla is community-based. OEMs tend to do things in a proprietary way, though, don't they? So how do you merge the two worlds here? It's quite a challenge. We have OEMs who want to do things proprietary. In some cases, we can't even name them or talk about them. We might say the keepers of the rill, to avoid actually saying the name. But we have all these people who, are doing things in a different way. We have all these cultures sort of combining to test this product. And how do we do it? How do we leverage everything? And that's kind of what I want to talk about a little bit. Let me give you a little bit about what originally was called Boot to Gecko. Now it's Firefox OS, what the architecture is, so you can kind of get a sense of how everything works. On the very bottom layer, we have our kernel. It's the gonk layer. We call it gonk. It's the kernel. It's the stuff that directly accesses the CPU and so forth. Directly on top of that, we have the same rendering engine that we have in our browser. So analogous to WebKit is, of course, our Gecko. We have obviously all of the same JavaScript APIs that were there in the browser before, all the same HTML5 rendering stuff going on. Of course, we've also added a few other things. We've added, obviously, the web APIs for all the things I talked about, like SMS, telephony, the vibrator API, and so forth, accelerometer, you name it. There's more than 20 of them. There's also a permission manager as well. So if you go to your browser and you type about:config, at least in Firefox, sorry, I shouldn't assume everyone uses just Firefox, but if you type about:config in your browser, you're going to see all of these security settings that can be toggled on and off, well, the security and other things as well. This permission manager kind of works in the same way, right? You obviously don't want a web application coming from some strange place on the web and suddenly accessing your dialer or accessing your camera and taking a picture of you at inopportune times. Therein lies the usefulness and utility and necessity of the permission manager. Of course, in the very top of that is Gaia. Gaia is our user interface. So Gaia is written in HTML5, CSS, and JavaScript. Unlike iOS, unlike Android, there's no basically application stack in the middle. It's just the kernel, the browser rendering engine, and then everything in the UI is written in HTML5 and such. And it's kind of ironic because the browser app is actually an HTML5 app, but it's using the same browser that ships with the device, right? Why has this become so interesting and useful? Well, a couple of doors seem to get open with this, and one of the doors open is, well, carriers. People like Telefonica or Etisalat or Deutsche Telekom, for example. They want to be able to have more control about the user experience that they're presenting to their customers. Maybe Telefonica wants to offer 3 different. For example, they might want to offer like 3 different packages, like a premium package and a regular package and a cheap package. I mean, whatever the proper sales terms for those things are. They want to be able to control that user experience, right? Instead of taking what iOS gives them and saying, well, you don't really have any choice. You can't change this. You can't customize and make it look. So the carriers have more choice. And when you consider also that, I mean, how many iOS developers are there in the world? I would guess they probably number in the thousands. There's probably hundreds of thousands, if not millions, of Java developers as well. But how many HTML5 or HTML developers, web developers? There's infinitely bazillions of them. I don't want to say infinite, but there's a lot more, right? And so that's one of the compelling things about this is opening the choice. There's suddenly more people who can develop it. There's suddenly the carriers have more choice of what they want to present. So I think if you were to ask me why did this take off and not like WebOS or something like that, I think this is why. It was designed to open the market. It was also designed to drive standards as well. But this is a bit about the architecture. Just a bit about how we do things sort of concurrently when we're working through the things. We have actually several different build processes and validation processes going. So while development is going on, here we have 1.0, 1.0.1, and 1.1.0. We have obviously different testing activities going on. And I'll talk a little bit more about those more specifically. We have builds we have to test. We have OTA updates, over-the-air updates, which have to be tested. Every patch that gets checked in, whether it comes from a community or whether it comes from one of our partners, we have a review and approval process, and it's the same one. It's the same process that we've been using to preserve the Firefox browser for all these years, and keep it running reasonably well. So it's kind of a useful and proven strategy in some ways, although not perfect. There's always things that can be done better, and there's always mistakes we can learn from it. Our partners actually are the ones who drive our bug triages. So when any of these development trains are going on, we have partners also working concurrently with their own forked versions of, for example, Gaia and the Firefox OS. So they can drive, for example, prioritize the bugs they want fixed, the features they want in their specific implementations. And we try to sort of offload as much of that as we can, right? Because Mozilla, the core people at Mozilla is actually very small. And while we do rely on community, we can only expect community to do so much. So we want to give more control to the partners, but that means it has to go both ways, right? So here are some of the testing frameworks that we use. There's a continuum there from functional to non-functional, and you'll recognize certainly many of the things here: XPC shell tests, Mochi tests are regression tests written against Java APIs. IDA-ticker, obviously, are performance tests. We have JavaScript unit tests. We have a web API JavaScript. We have Moztrap, which is basically it's a repository for manually executed test cases. So we still do a fair bit of work manually. And this is always the first, when you have features that are brand new, for example, a GUI that isn't frozen yet, or an API that's not frozen yet, it's often useful to tinker around with a little bit of manual or semi-automated testing before you commit to the automation. I mean, this doesn't replace, obviously, JavaScript like unit tests, if you will. It just complements them, right? It's just another way to approach the same problem. We have marionette tests, which are written in JavaScript. Ref tests, which Rebecca was good enough to talk about. We do, obviously, a lot of those. And these balls, by the way, approximate the actual size of the test base that there is. So our Mochi tests, which are analogous to Mochi Kit, written in JavaScript and testing DOM and in JavaScript APIs, are some of the biggest tests we have. So when we had all of these tests, we had something like 80,000 of them already running on Firefox browser. It was a matter of flipping a switch, and we were able to report them and suddenly run them on Firefox OS as well. So we didn't have to re-engineer a whole lot of our test base from scratch, only for the new APIs. And this is, I mean, I thought this was incredibly powerful, actually, that we were able to do that with very little adaptation. Obviously, crash test is another thing that's here. Here's an example of Mochi test. Actually, this is the HTML portion of it. You can see that it loads a window when the window is loaded. It does this simple test thing. Sorry. It does this. It's running a simple test call. So I could show you the code for that, but you basically see that when this window is launched, it's running a test. This one also is doing something about the enabling the security privilege as well, so that the test can run, right? So that's sort of, at a glance, what the security model might look like in code. A marionette test is actually our automated functional user interface test. So this, you will see, it looks quite a lot like Selenium. We obviously got a lot from Selenium, and we're able to almost immediately leverage it to test user interface elements against the different versions of Gaia that we're coming up with. And now, obviously, what a lot of our work is not only getting community to contribute tests, but also training the partners out so that they can write the tests as well. So that's what that looks like. To give you some idea of like the depth of the testing that we have, and this is, of course, spread across community. It's spread across our OEMs, our carrier partners as well, and our different contracting groups. I mean, we do the user stories to test cases things. We still work with real requirements. We have daily smoke tests. We have one batch of daily smoke tests, which we're actually running manually. And this gives us a perspective on how this phone is going to behave on a given day. So while we do automation, of course, and pretty comprehensive automation, we still do a fair bit of manual testing just to see what things look like, to get a sense of that. And we still take that work actually very seriously. Quite a few test runs, full functional test runs between the code freeze and code complete cycle. These are, of course, both automated in manual tests and happening at all levels. We have test results for both the rendering engine Gecko as well as for the user interface Gaia. In our case, it's called Gaia right now, but there could be many different user interfaces. Performance metrics as well, crash reporting, and so forth. Obviously, a lot of doing is a lot of what we do has to do with identifying bug blockers. So filing these blocker bugs, finding these things that prevent us from working, filing them and verifying them across the range of phones that we support, and so forth. And obviously, our dog fooding program, where we have people beta testing the devices. We have the Keon Geeks phone now, which is one that we're using. This brings us another dimension to that as well. Our test coverage is literally kind of happening on this project all over the world, and this is no longer a complete picture anymore because we've added a fair bit more. But to give you a typical idea, we have the stuff we're doing in Mountain View, which includes API automation, the UI automation, as I mentioned, performance testing, obviously studying features and defining the test cases, working with the product people, bug work, and almost all the coordination happens from Mountain View as well. One of our partners here, Telefonica, does the features that they own, right, some of the same things, but they still rely on us for coordination. They're doing a lot with the communication apps, the cost control, of course, their own triages, their own bug work, and so forth. We have a team of contractors in Kirkland, Washington that we work with. We also have a branch in Taiwan that's working with a lot of the radio-intensive features as well. In addition to this, I just came back from a certification round in Chile. So now we're certifying a bunch of phones for all the Latin American countries. And this, of course, brings another dimension to this model as well. So a lot of that stuff is driven and run by the OEMs, but it still falls on us because in a way, we're the only ones kind of sitting at the center of this puzzle who can see the whole picture. And that's why it's interesting and useful to us. So where does community fit into all of this? We do some of the kind of things in some way, like the Test the Web Forward that Rebecca was talking about earlier. I mean, we organize hackathons and meetups and groups and things like that. But it's a matter that the big challenge is keeping people engaged. I mean, how do you weigh it when you need somebody with a lot of money to come and fund you, and you need to protect their proprietary secrets and all of these things? But you also want to be able to leverage your community and keep things open at the same time. I mean, this is an ongoing challenge and one that I don't have necessarily a very good answer for. But it's one of the challenges we deal with every day. So it's a little bit about our localization as well. Localization is, by the way, one of the ways that community is most involved with us. So for example, we have 90 languages covered by 24 teams. I think there's actually more teams now. And these people are spread all over the world, of course, in addition to doing a translation. As you know, L10N is also involved in a bit of coding, documentation, and testing, and all of those things as well. So they contribute a lot in that way. Obviously, we prioritize the countries that we're targeting first, right? This is a look at our Tinderbox. So this is where we're running some of our automated tests, and you can see this is, for example, our try-build system. So I can, for example, code a patch, commit it to this try-build system, generate a build of my own, and then flash it to my device, and then try out the specifics of this build without affecting anything else in the infrastructure. Anyone at Mozilla has a possibility to do this, to generate their own try-builds. You know, with all the other pieces in the puzzle kept uniform, it's very useful to be able to say, well, with this particular commit, and when I add this patch, then I get these results and so forth. This is an incredibly useful way to work, actually. All of these continuous integration systems tie together in Jenkins, and Jenkins kind of gives us the big picture, and I'm sure you're quite familiar with this. It's nothing new here. So, do you have any questions or any comments?
A simple question about Mozilla and your the partners, the carriers, and the people who want to jump on board for this effort. Being a nonprofit, open source, essentially, are they like funding Mozilla in a way? Is that the model for this?
In a way, they are. That's absolutely true. Yes. If a carrier wants to go to market with something, I mean, I can't comment on the specifics of what they commit, but they do commit resources in addition to people. I mean, there's also a financial aspect there. In some cases, they may help us bring to market. They may help us with, obviously, they're driving the certification with the OEMs through their own channels. So they're contributing in a variety of ways. Mozilla is, in a way, sitting at the center of this, but obviously, we're not the one funding it all. And we rely on those partnerships to make it go forward, obviously.
You said that vendors can make changes to the way the OS works. Are there any guidelines, or the vendors can make the Firefox or mobile OS experience crappy?
They can make it as bad as they want, because they're the ones who are going to be selling the phones. They have to live with the consequences of those choices, right? So if they made it look bad, it would ultimately make them look bad. I mean, if you consider like a typical a typical support call, right? How does it work now? So for example, I have this Verizon phone. If I have a problem with the phone, the first people I'll call is the carrier. In this case, if I have an iPhone, and I have a problem with the phone and I call Verizon, well, if there's a bug in the code, there's only so much that the carrier can do about it. So the carrier then has to go back to Apple, probably file a bug, probably escalate a support request, and hope to God that something actually gets done about it. And that's the thing. In our case, we're giving them the code and saying, well, okay, your first line of defense is you, the carrier. So you get a bug request, you try to fix it as much as you can. If you need to escalate something, then you can do that. That gives them the choice, and we hope that it makes it working a bit better. Yeah.
Any larger format tablets in the works for you guys, or are you just focused on smaller handsets by your carriers?
Right now, we're focusing on smaller handsets in the developing market. So one of the other points I should have brought forward is, I think one of the advantages of Firefox OS is that it can run quite well on a very, very cheap hardware. So we're focusing in developing world. We're focusing like second world countries, a lot of Latin America right now. Making a build target isn't a trivial thing, as you can imagine. So it takes quite a bit of engineering, reworking the kernel, and then reworking the build scripts and so forth to make all that happen.
When you say build target, is that per device or is it just per size?
Do you have any idea on projected circulation?
I can only throw a number out there. I know that the first launch, they're talking between 30 and 40 million, and that's going to be in the middle of the year. So I think at the end of Q2. Beyond that, I can't say.
Do you see any future for adopting more modern devices like tablets in the emerging markets?
Personally, I do. And if it were my decision to make, I would do something about it too. I see a future for it. I think that things are going to go. The cars are going to fall where they're going to go. So they're going to try the path of least resistance to get this thing to market, right? Which is the cheap phones in the developing market. I see actually more competition with other offerings that are out there when we start to head toward tablets and things, because there's obviously a whole lot more players there. And the question is, are we up to that? And I can't say that we are or we aren't, but I see a future in it, yes, but I think we're going to stick to what we know at first and try to make the best of that, and then see if over time this makes more sense to expand to those other devices.
Is there an easy way to transplant the Firefox OS to other Android-based device? Is it designing your architecture?
Again, it's a matter of making a new build target. So somebody has to go and look at the kernel and saying, does this kernel work on the device? And then they have to optimize the build script as well, right? So the Gecko needs to be built against whatever kernel is there, and that kernel needs to be developed against whichever hardware. Another variable piece that makes this kind of complicated is the RIL, the radio interface layer. So that, in many cases, is a whole lot of proprietary code being driven by OEMs. So in order to do a new device, you need to consider a build target. So you need to consider your kernel. You need to consider your radio interface layer. You need to consider also optimizing the build scripts and so forth to point to all of those things. So it's not trivial and takes a bit of investment and effort to make it happen, but it's doable. In fact, I think that
Some of my friends say that Gecko is based on Android platform in its firmware layer.
yes, we use ADB, for example, for debugging. So when I use debugging, I use Android Debug Bridge. That's no secret there. So yeah, we're based on the Android kernel very much.
Is there any idea that one app for one phone should work for other phones? Firefox OS?
Actually, yeah, the whole point of the web app thing, and I should have talked about that, thanks for bringing it up, is that the idea of writing a web app is, it's quintessentially write once, run anywhere. So if you write a web app in HTML5, say you write a game or a Twitter app or something, I mean, there's different levels of apps too, and we can talk about that. But basically, the whole idea is you write it once, and you can run it anywhere. So you can run this not only on a Firefox OS, but you can run it in a desktop browser. You can run it in an emulator. You can run it in another device or the Android stock browser even. The idea is write once, run anywhere. This brings up actually another very interesting point about leveraging bandwidth and leveraging the footprint of the applications, right? You can have an app that's written completely in CSS, HTML5 and JavaScript, and it has all the functionality there. And when you download this app, you're getting the whole app. You're getting absolutely everything. IndexedDB, storage, it's all there on the device. You can also write an app in such a way that most of it's running from the network. So all you're really getting is an iframe, and it's pulling the rest of the network. What's interesting there, and where there's some focused loci of control there, and what's compelling to the carriers is if you're in a place like Venezuela, for example, or Brazil, where the networks are generally god-awful slow, it's better to ship the device with a bunch of stock applications that are already mostly there and are only occasionally pulling from the network and refreshing their data. Instead of trying to have only an iframe there, in a country like Poland or Estonia, which are very well-connected countries, with very good web infrastructure, for example, it makes more sense in many cases to have just the iframe for the apps and be pulling down most of the application content remotely. So vendors can control that. Carriers are very interested in being able to say, well, our network kind of sucks here, so we're going to make most of these apps available and just refresh the data. Or if they're in a place where the bandwidth tends to have more throughput, then they can do it differently. But the point is that they can scale that, they can control that. And that's, I think, why it's caught on with them so much.
How about the stores for the vendors, or is that undecided?
So the whole plan is not to have one proprietary store. Anyone can set up a store. So there's not just one app store. And you have to spend a year of your life writing an application and then have Apple tell you, oh, screw it, go away. Anyone can start their own store. Anyone can create their own store and host it remotely, host it on the devices, and do whatever they want. By way of example, so the first devices we're shipping with, the store was done by this Everything.me, this Israeli company, that actually did a pretty good job of creating, in many cases they're just iframes for like Twitter and Facebook apps and stuff. But they also have a nice mix of like full-blown web apps there as well, and quite many of them. So they put together a web store. We also have the usual Mozilla marketplace, which runs on these. But the point is that anyone can create their own store and populate the store. So we're trying, instead of to create a closed silo, we're trying to open things up.
So on the app topic, since you're getting all the this government away, how are you going to ensure there's no malicious apps built out just because we can?
I think that's going to be the same kind of effort that we've seen with malicious apps in the browser ecosystem. So if you consider what data security companies like F-Secure do, is they get threats from a variety of places, they assess those threats, and they make like a disinfection or a cure. I kind of think it's going to work the same way in Firefox OS. If I can hazard a guess, people are going to do bad things. That's just the nature of humans, right? We can't really prevent it. What we can try to do is provide as many variables for controlling the things, for limiting possibilities for these things to do much worse, and then enabling the bigger community. I mean, we're still going to depend on whatever the data security companies, whatever the communities out there are finding, to help that happen. I don't think that Mozilla is in any place whatsoever to offer like a complete security model for a phone. I mean, but we can put it out there. Thank you very much for having me.